Hi, I'm Callum Moffat. My project focuses on making glucose monitoring in newborns less invasive through a colorimetric analysis. Currently, newborns often endure heel pricks roughly every 20 minutes for blood glucose testing. This can lead to lasting trauma, diseases, and bacterial infection that are highly detrimental to a newborn's body. My research question was, can artificial intelligence accurately predict glucose levels in unknown samples by recognizing patterns in absorbance from a standard calibration curve? I tested the null hypothesis that there would be no significant difference between AI concentration estimates and measurements from a professional UV-Vis spectrophotometer. I started with preliminary trials using blue food coloring and water to test AI's color detection ability. From this, I found that AI was highly accurate in detecting colors, and I was able to move into my glucose assay. To conduct the assay, I worked with Dr. Dylan DeMail at the Colorado School of Mines. I performed a serial dilution to create a standard curve that included two unknown concentrations. I added enzymes horseradish peroxidase and glucose oxidase, along with the substrate that turns the solution pink based on the glucose concentration. Once the reaction was complete, I took photos on my iPhone for the AI and used a spectrophotometer to establish my baseline absorbance values. For the analysis, I collaborated with Claude AI to develop a program that reads RGB and absorbance values from an image to create a calibration curve. In my initial visual analysis of the spectrophotometer graph, I predicted that unknown 1 would need to be significantly larger than the other samples, while unknown 2 should be roughly 32 milligrams per deciliter. When I ran the AI program, it estimated these unknown values with high accuracy and low variability. I found the estimates were most accurate at concentrations right around or inside the calibration curve, while accuracy decreased the farther AI had to extrapolate the trend line. Statistical analysis showed that neither value exceeded the critical limits of a chi-squared test. Therefore, my null hypothesis was supported, strongly at concentrations within the curve and weakly at a higher end. The main sources of error in this experiment were photographic errors, like shadows and glare, and the need for AI to extrapolate that trend line far beyond the calibration curve. In the future, it would be beneficial to center the calibration curve around the expected values. For the newborns, this would be from about 20 to 110 milligrams per deciliter, as well as to use more refined photography techniques to reduce glare and shadows. Overall, this method is far less invasive because it can be used on human urine rather than blood, and is highly accessible since the AI program can be run on any smartphone, tablet, or laptop with the ability to upload images. With this refined photography and a targeted calibration curve, this could be a very transformative method for newborn care. Thank you.